concept of an internal developer platform, or IDP in short. And then I'll touch upon how you can build your own IDP using, like I said, Amazon EKS and your choice of open source solutions. And also, importantly, why you should really build an IDP. And the lastly, we would hear from Manny, my friend and colleague from Adobe, how Adobe has built their own world-class IDP, and they would love to share their learnings with you as well. So let's get started. There was a recent study which was done by one of the leading marketing intelligence firms, IDC, and it said that in the next few years, there would be more than 500 million net new applications that will be built. And this number of 500 million is more than all the applications that have been built in the last 40 years combined. So what the statistic is telling us is that the pace of innovation is only going to increase from here on in the next few years. And so what really means is that customers would really need to move faster. They're going to have to figure out how to innovate even faster. And what we've seen with Gen AI in the last few months is that our experiences have been really evolving very fast, and things are changing. Simple things that we used to do maybe a couple of years ago, they would become probably completely different in the next few. And so companies would really need to adapt. They would need to learn fast, fail fast, and move on. But bottom line is that they will need to innovate fast and really accelerate the time to market to remain competitive. And some of the ways to remain competitive is to build self-service tools that can really help you onboard new services or applications to your landscape. Not just that, but also to onboard engineers. We've seen that it takes years, not really years, but like weeks or months. And what we really want is, new developers to be able to really build their own code starting in minutes and not any longer. But you know what? Speed is not the only thing. And our customers are telling us that they really need to maintain control across a different number of vectors. While they are telling us that they would need great insights into their applications by using logs and metrics, but at the same time, they would want their applications to be more reliable and scalable. And then for all the people who run their applications in cloud, they would know that security and governance is in itself a whole new dimension. What you would really need to do is perhaps have strong security and governance policies which are in line with your company's governance policies. And while we talk about a modern application, we're not just talking about running applications using containers or serverless on AWS, but it also means maintaining all those controls that are mentioned in this slide. And the challenge is that while these tools are great, integrating them is extremely complex and can take a lot of time. Now imagine you're looking at one application and the challenges that it takes to integrate all these tools. If you were to maybe amplify that to thousands of applications across the whole organization. We'd be lucky if you have only tens, but most likely you'll end up in a large enterprise with hundreds of different unique tools and products that you're going to have to manage. So now, this is a real situation where we've seen within a company there are two different business units running their own security best practices. So it's not just about the best practices going for a cost, but even the cost optimization that you may want to have by having a better pricing power with few vendors, that also changes completely. So one of the solutions to the problems that I just mentioned is to build your own internal developer platform. Basically, everything which is underneath your application code is now part of an IDP. So while you can run like a modern compute using Amazon EKS or perhaps Amazon ECS or Lambda, you would need to like I said, manage a lot of operational tools as well. So everything except your application code is now part of an IDP, and it is now managed by a central team with dedicated resources. So amazing developers can really manage your own code. So this is how an IDP would now look like. Like I said, you run your own modern compute using Amazon EKS or any of the other choice of the modern compute platforms, and then everything else underneath is managed by a central team. So amazing developers like you are really just focusing on building your applications. In short, what we are saying is that by building your own IDP, you're able to not just gain the economies of scale, but what I started with, speed and control is also something that will come to you. So this was a short introduction about what an IDP would look like, but now to hear more from Manny about their learnings and how Adobe built their own IDP and they're running at scale, please welcome Manny on stage.
So I'm Manuel Solino. You can call me Manny. I've been a senior engineering manager at Adobe for a few years now. I'm really focused on our developer experience. That's what my team is focused on. The greater team that I'm part of actually runs the IDP as a whole. And first off, I want to walk you through kind of our landscape at Adobe. Now, you probably know we have 3 different clouds. All of the applications you work with on a regular basis, whether it's Illustrator or Acrobat or Experience Platform, is going to be in one of these clouds. All of those sit a layer above our platforms. So you'll see Content Platform dealing with all the proprietary formats that we build out and ship products on every day. Sensei, which is our machine learning and AI platform, that's been critical to a lot of our recent strategies now with Gen AI. And all that bakes up into products. Data platform, we do tons of analytics. All of that goes in the data platform, and we try to ease that away from products we're building around data. And ultimately, IDP, and that's what we're going to talk about today. We want everything at Adobe to depend on us, and we try to abstract away a little bit of the cloud work. We bring runtime to these services. And we still let them call it to the cloud if they need specialty services like CloudFront, S3, RDS. They can still manage their own data, but we try to make their lives easier in some ways, and running the application is a big part of that. So we did do this survey. We did talk to a lot of folks at Adobe. It does take more than a month to get a service up if you have nothing provisioned yet. You need Splunk, you need New Relic, you need some kind of monitoring, whether it's Prometheus, otherwise. All of that takes time to set up, especially if it's a third-party vendor. And a lot of that is tied up in ticketing systems. So you have your 0 to hello world journey, which is what we call it. You want to deploy your application, do your trainings, create your tickets, ask for provisioning of XYZ service. You need your team to talk to whatever thing under the hood. There's usually a wait time there. People go on and they start figuring out how to do the CI/CD. They figure out what APIs we can consume, what libraries do we need, and then they come back and they deal with the response to those tickets. So all of that back and forth ends up with this month of wait time. It's not fun, and I think this is something that we really wanted to address with our data platform, our developer platform, sorry. Now, what we did was build the platform on Kubernetes. We used these swath of open source tools. Now, we're running about 250 clusters today. We're doing at least 4.7 million containers a day. That's changing constantly. And the same thing with deployments. We're doing at least 200. That number is constantly going up. It's probably way more than that today. But this is to give you an idea of the scale we're working with. A big part of what I want to focus on today is CI/CD, which we do with Argo, and our developer portal. That's part of Backstage, which is an open source solution from Spotify. Now, even though we have this broad amount of open source tools, those two are really the areas that I think drive developer productivity as quickly as we can, and really help them deliver the product faster. So as much as it is about getting started, it's about day-to-day, how do you get software out the door. I will walk you through quickly everything that we're running. So for logging, we are using Fluentbit. That's for shipping logs directly from we run as a sidecar, so ships logs directly from a pod to your logging storage service. Monitoring is Prometheus, tracing is Tempo. I mentioned Argo for CI/CD. Envoy is what we're using for load balancing. HPA is our auto-scaling solution on the clusters. Service discovery on cluster is using Core DNS. Network policy is Cilium. For runtime security, we're using Trivy, which is an open source solution from Aqua. That'll scan all the containers going into the system. Developer portal is Backstage. Cost allocation is OpenCost. That's something that we actually partnered with KubeCost, AWS, and a few other folks to launch. It's actually one of the better tools I've seen out there for tracking per pod, per cluster cost. And the artifact store, honestly, we love ECR. It's been one of the most reliable things for us, so this is another area where we take advantage of AWS for scaling out with this many deployments. I do want to call out EKS here. We did run our own control plane for a long time. We found that a lot of these tools, Argo workflows, ArgoCD specifically, rely very heavily on Kubernetes control plane as the data store and kind of request management system for everything going through it, which is great. It actually gives a lot of fluidity, flexibility to what clients want to do on there. And everything's in Kubernetes. We can create policies around it. If you know Kubernetes, you can work with this. But it really pushes the control plane to the limit. And that's where EKS has helped us go really far, really fast. We have, I think, worked with AWS on all kinds of weird things that we did, misconfigurations, things that we pushed EKS to its limits, and really they have been great partners in helping us figure out how to do things in a more balanced way, understanding how EKS works and how we can really optimize that flow. So I think it's really gotten us really far with all of these open source solutions. Now, I do want to start on the developer journey. Here is where any Adobe developer would come in and begin their service deployments, service onboarding, however you're starting. I will call out on the left-hand side is the two of the first things that we put in here, which was the service map and the service catalog. This all launched in June, so we're trying to figure out what's the most valuable for developers immediately. The service catalog is every service at Adobe, who owns it, something about it, how do I find out what's going on with the service is there. Service map is the glue between all of those services. Which service depends on another, what other monitoring systems are they using, are they having incidents, all that gets highlighted there. Now, I'm going to go to the bottom real quick. Contributor plugins is a way to contribute a plugin directly to Backstage. This is something that we're kind of betting on. We want all of Adobe to be able to contribute to this portal. It's not a thing that we own, but something that anybody can bring their needs into. And that's where Backstage has been great so far. We hope it continues to be great. It has a great data model under the hood where you can mix and match API information and bring that into an experience that developers can learn from as they go. It can bring insights about other systems that maybe they're not aware of, or you can create screens where the two systems kind of share data and bring that to the developer's awareness. So we're hoping that we get a lot more contributions from around Adobe, and we can reduce the currently 40 portals that developers have to go to manage their system down to one. Now, let's move on to templates. Another feature of Backstage, that's basically a way for you to scaffold an application or even technically a workflow within Backstage. I think we kind of use it a little bit and really push it to its limits, but we're using templates as a way to provision, planning to provision a great number of things. What we're starting with now is how you bring up a service at Adobe. So we have code generation. This is something that we've done for a long time, and we basically ported it into Backstage. We support Go, Python, Java, and Node. And we do have something called Adobe Service Runtime. This is a series of Java libraries and connectors that help you integrate into Adobe services more quickly. So you don't have to worry about writing all these things and kind of get you bootstrapped. Java is the biggest language at Adobe, so it is an easy choice for us to really invest there. And that's another area where we've seen great community contribution. So I think we kind of love having Adobe developers be part of what we're building, and not just something that we're serving out to the rest of the companies. And then finally, all the way to the right, is how you actually onboard that service. So you come in, you generate your code, get that set up in Git. We give you the Docker file, the make file, everything you need to get up and running. You then say, hey, I want to onboard this. We then kick you off into a system we call a provisioner. We'll ask you a bunch of questions. Where do you want to run, region, cluster, what are your cost centers, who has access to the service, and then populate that into a YAML file that sits with your code. And that YAML file will be interpreted by the provisioner and start setting up your namespace, load balancers, ingress, anything else you need to get up and running. That will also set you up in Argo. Now, I don't know who's seen Argo, but I want to highlight what it looks like. It's a lot of data, and if you're a developer who doesn't know Kubernetes, this can get overwhelming. Workflows, very simple on the surface. As soon as you click into one of those, there's init containers, main containers, logs for all different kinds of things, and if you don't know what the difference is, you can get lost there as well. We still have a way to go, but what we started doing was simplifying that for developers that didn't know Kubernetes. How do they get their service up and running quickly? So what we did was create this dashboard where we link out to data that you need, give you insights into what the status is of your application. Right now, this hub configuration is out of sync. And just to highlight the hub configuration versus remote, we run a hub and spoke model. So we have a Kubernetes cluster running ArgoCD, running Argo workflows. We create a namespace for you there that's your CI/CD namespace. You can do whatever you want in it. We monitor it, we have policies around it, but basically it's your place to run your CI/CD. We then also have a remote namespace, which is where your service is defined. That is where you are actually serving your application, DNS at the bottom. This is the public-facing application, or it can even be internal-facing. We have restrictions around corporate-facing applications. And we'll give you that information at the bottom, DNS, what containers you're running, the health. You see this one's not doing so well, someone's got to dig into that. And links to the specific applications and other dashboards we have available to you. So we have red metrics, which is rate, errors, and duration. That's a freebie, I guess, that we offer up to anybody on the clusters. As soon as you run your application, you can kind of get that data about your service, see how you're doing. You can then extend the monitoring. You see this developer actually does have Prometheus running, Alert Manager running within their namespace. That's something that they've opted to install. We do provide a template for all of that, and they basically say, hey, just add this to my Helm chart. I would like it, please, and you get all of this for free for the most part. And this also helps us with kind of resource management. We're able to determine how many resources, CPU, memory are consumed by that namespace, and that's allocated to the client. So since every customer, everyone that we consider a customer, owns their namespace, we're able to associate who's running what, who owns what. Helps us with management in a big way. So I talked about templates. I want to get into the kind of flow here. So we start with templates. This is a bit of a challenge, but it's an important thing for us. So we create a template, it's a Helm chart that all clients will inherit. That determines what we think a healthy standard service looks like. We have definitions for workers inside. We have definitions for ingress and all that abstracted away. The developer really just has to worry about the values file for that. So they pass in values file. We've told them here's all the settings you can change. They're able to kind of define a pretty good service, whether they'll monitor it on or off. We even try to do some of that from the Backstage UI for them. We also create the standard deployment workflows for them. So let's say you need to build an image container, you need to have that scanned by Trivi, you need to ship that to PCR. We provide all that out of the box. We then also have some more advanced deployment strategies that we try to manage for them. So we do a stop and wait step where you get to stage or dev, whatever your first environment is. It'll then pause the workflow there and wait for you to then say, hey, promote me before it moves forward. The other thing we kind of provide is different unique expansions to those workflows. So this is things that we've had contributed from around Adobe, and we're hoping for more, but there's unique AI model builds that needs data pulled from certain places. They need special levels of access to certain S3 buckets. So we've had the Sensei team actually bring that in and contribute those as optional workflows you can extend your templates with. Now, once you have your template set up, we provision 2 repositories. There's an application repository that's your application code. Then we have the deploy repository. The deploy repository is the state of your universe. It knows everything about your workflows, the hub namespace, and your service namespace. Anybody on your team that has access to Git can go and reconfigure your application anytime. So Git is the master of your domain. You want to make sure that you have access control managers there. Everything should be through a PR and get reviewed, but it gives you the most level of awareness and insight into what's happening, and it gives you change management out of the box. I'm sure most of you have heard the term GitOps. This is basically what we're trying to encourage at Adobe, so this is how we do GitOps at Adobe. The nice thing too is, with all workflow changes happening inside of Git, your whole team knows when you've changed CI. When CI tests start to fail, when something's gone wrong, you have that history there, and it's very obvious. There's no configuration in some random box somewhere that you weren't aware of. So this visibility is something that we're hoping that the entire team benefits from, and eases communication within teams, especially distributed teams, which we're a global company, we have teams working together across the globe. Visibility and remote work matter. Yeah. So, moving forward to the actual flow here, your first provisioning, you've gone through that Backstage flow, you've come here, all the templates landed in Git. The provisioner said, hey Argo, you should pay attention to these repos. Argo's like, I got it. It then goes out and creates the hub namespace, creates the remote cluster namespaces. It provisions all of the Helm charts into those namespaces and gives you a kind of basic layout. You probably won't have an application running at that point because you haven't done your first deploy, but your environment is set up. Now you go in, you do an application change. That application change goes into your namespace. And like I said, we do everything in the client namespaces so that they own the whole process. The namespace receives an event in our project. It's not highlighted here, but it's called Argo Events. It's part of the Argo suite of projects. It receives that, then forwards it to workflows. The workflow is then triggered. It'll go through image build, scan, yada yada, and push to ECR. At that point, we have a step that we created that actually writes back the SHA that we've associated, that we tagged your container with, to Git. So this means that everything is, again, referencing Git, is the state of truth, and it's using the SHA from the application repository. This sync is then triggered in ArgoCD. It tells Kubernetes, hey, I now know what the application image is. We can make this healthy, and starts the sync process. Kubernetes will then pull down that image from Artifactory, and the world should be right again. You'll see that shown up in ArgoCD, the green check mark, and saying everything is healthy and everything is safe. Did I miss anything? That's good. All right. I did want to get into some of the lessons we've learned. I mentioned community like 3 times. It's very important that I talk about this specifically. Inner source is open source. If you've heard about inner source in general, it just means running an application within a company as open source. So it might be proprietary, but you're opening it to everybody who you can to contribute back to it. This is where I think we've succeeded in a big way. We really want contributors to know what they're doing, so every repo does require documentation. It requires tests. Some CI is set up already that we'll just kick off and give them feedback right away. We really invest a lot in community. We actually have a team that is just thinking about this, so that's how do we support them, both as users and as contributors. How do they get feedback? How do they get PR reviews? It is an ongoing conversation that's always challenging, but this is where we learn from open source communities. What are successful open source projects doing? And always build and be open. Document stuff, publish wikis, let everybody know what you're doing, what you're gonna do. They will be unhappy sometimes, but some things are necessary. We are also the bastions of compliance and security, so not everything's a popular choice, but it's better to just publish it and put it out there. IDP is a product. This is something I've learned. We worked with a product manager for a long time. If you can get one, use them here. If not, see someone from your team who's willing to step into this role. Any feedback from the company and everyone around you is really important. Not only talk to your own team, and hopefully you can have them consume some of these products themselves, but any other product around the company that might take advantage of your portal, someone you want to survey and understand. And simple things, I mean, NPS, easiest thing ever. Get it out there so people feel about your platform. You want to know how long it takes them to get started. You want to know if they're using the docs, what docs are the most read. You want to understand kind of what are the challenges for anyone, whether they're onboarding or trying to contribute. Yeah, and then really, finally, there's no platform without adoption. I think this is one of the biggest challenges, and I'm going to talk about Gen AI for a second because this was a challenge we had this year, and I'm sure a lot of other people have. If you've noticed, I've used Firefly to generate a lot of these images. They were one of the first major products that we kind of accelerated through the pipeline by partnering with them very closely. This was an important thing for Adobe, and we were basically able to get them from like theory on a laptop to production in about 2-3 weeks. We did an internal beta for a while, matured that, and then got them out to the public in a few weeks after that. So it was a lot of work. We were not planning on launching this with this IDP at the time, but it happened. We knew that's where Adobe was going. We knew we had to be part of it. And we already had the pieces in place. We got the gist, we got it mostly right. But we did have to adjust our priorities and our plan. And I think it was a great success. And I can do things like this now, it's a lot of fun. But be ready to pivot to what your company needs. Understand that your internal partnerships are the most important thing. You need to understand where your products are going, what they need from you, what the balance is between your priorities and theirs. And make sure it's easy for people to get started. Get started contributing, get started using the platform. I'm a developer by myself and I have an idea. How do I do a POC of this within the company? That's the audience you want to target because it's easy to adopt. Then people will come. That's the only thing. If you build it, maybe not. But if it's easy to adopt, people will definitely start using your platform, at least trying it out. I think that's going to be the biggest game changer for adoption of the company. Cool. And I think we're here. You're up. I'm going to come back up, wrap this up.
Thanks, Manny, for sharing how you do and what you do. To make it easy for you to build your own ADP and at least to get started, we've combined a few resources that are on the screen. These are contributions from AWS and also contributions from Adobe. If you have any questions, Manny and I would be outside the room to answer your questions. Well, thanks for coming.